Hello there. Hello. Right. So this is this is Kenwood 590SG. That's a model which I bought in November 2015. It's pretty nice and powerful piece of instrument for any serious ham operator. Um, However, I've noticed from some reports that the frequency, the center frequency of my transceiver is actually a little bit off. Actually, this is because of the local oscillator inside. It's not exactly tuned to the best possible accuracy. So what I'm going to do is actually adjust the internal frequency of the oscillator. On page 77 on the Kenwood manual, there is one section called reference frequency calibration, and this is what actually going to do. Not exactly the same procedure, but more or less, I'm going to try out to find out actually how I can adjust myself the local oscillator frequency of this transceiver in order to be as fine-tuned as possible with the reading on the screen. Right. So one way to do this is actually tune your 590 into a world standard clock, say at 10 megahertz, the one I decided to pick up, and see actually how much is the frequency drift of the local oscillator. So I choose CW, fine tune, because we are going to play with very fine adjustment of the frequency. And now let's turn up the volume to see what we hear here. Right. This is a single carrier frequency that the world clock is sending at 10 megahertz. I have connected the 590 with my computer in order to check on a waterfall display the exact audio frequency of what I'm listening right now. So this is FLDG actually. FLDG, one way to do it is with FLDG. It's been connected with the 590 using a USB cable. So right, so first of all I have to fine tune. If you look at the top left corner of the display, this is okay. I have now changed the frequency exactly to 10 megahertz in order to match the frequency of the world clock that I'm now listening. So if I go on the waterfall display and I look in very carefully, I'm going to see that the waterfall display, right? Oh, it's not clear, is it? All right, now it has zoomed in. Is centered somewhere above 1000 hertz. So if I click here on the center and then I check down on the bottom, I'll see that it's actually 1038 hertz. This is the sound, the frequency of the audio that I'm listening right now. First of all, I just want to clarify that because we are on CW mode, the pitch frequency is actually dependent on how you have set up your pitch on your menu. So if I click menu and you go to menu number 40, I have adjusted my pitch frequency, the side tone, the so-called side tone, to 1000. So I have CW, and whenever I receive a signal on the received frequency, I should listen something on 1000 exactly, more or less. Right. It's also possible to change this value, but then if you go back to FLDG, you have to make sure that you follow this waterfall line accordingly. So right, okay, I have chosen 1000 for practical reasons. Okay, so over here it's not 1000. My center frequency should be just on the 1000 line, and it's over here, which is something like 1039 hertz. So, oh goodness me, I'm 39 hertz off. So this is a problem. Instead of listening something which is 1 kilohertz, it's actually 1.039 hertz, kilohertz, sorry. So that's 39 hertz off. Okay, so that's the reason actually I'm going to follow this procedure here and try to calibrate the local oscillator of the 590SG by adjusting a small variable capacitor located underneath my unit. So I'm going to unscrew this and see what's inside. Okay, according to the manual, I have to take off 10 screws from the bottom of the case. So these are the screws. I have turned this upside down. Okay, let's unscrew and see what's inside. Right, so I have now removed the screws, and what I've noticed is that if you want to remove the back cover, you have actually to push the cover this way. So if I do this, I have to use one hand. Okay, can I do it? Right. Okay, let's push it this way. Okay. You have to push it this way. Right, so let's remove it. Okay, I have removed the rear cover. Okay, the situation is a little bit scary down here actually. There is lots of stuff to see around, but our local oscillator can be adjusted with the help of a variable capacitor that is located actually over here. It's this one. It's very, very tiny. Oh, this is going to be a nightmare actually to adjust. It's over here, it's this one. I can see that I need... Okay, let's put the light a little bit closer. I need a screwdriver which is straight. Okay, let's see closer. Yes, this is a very small capacitor. Okay, let me find the appropriate screwdriver for this purpose. Right, so I just realized that the screwdriver has to be really very, very tiny in order to fit into this capacitor. Okay, and also I realized that when I'm touching the screwdriver with a capacitor, the frequency is changing slightly on the audio part. So you can see that the change there. Actually, this change happened, I realized when the screwdriver actually touched the capacitor, because the metallic part of the capacitor is changing the capacitance of the whole thing. Let's try to adjust the audio frequency as better as possible. This is just very sensitive. When you turn the screwdriver clockwise, the frequency reduces, and when you turn the screwdriver anti-clockwise, the frequency increases. So okay, I need to reduce the frequency, so I'm going to turn it clockwise very slightly, and let's listen to the audio. Oh, this is too low. This is now 960, 70. I need to put it up anti-clockwise. Right, back to the felt digi. This is my first attempt here to adjust it let's put it on the slow speed, right? And then I just readjusted the capacitor so it's closer to the 1000 kilohertz audio signal. So it looks pretty cool right now. Okay, let's try to find out exactly with a mouse where this is. Okay, it's 1000. Okay, it's 1002 hertz. Okay, okay, that's much better. Generally speaking, we would like to do this oh, excuse me, this adjustment after several minutes, maybe half an hour or more, when the device has warmed up quite well, so you actually simulate the conditions which will happen when the transceiver has been used for some time, because when you turn on your transceiver everything is cold, and taking into consideration the fact that the local oscillator frequency is greatly affected by the temperature of the PCBs, the chassis and everything. This means that if we're going to have a long-term stability in our system, we need to let the transceiver stay on maybe for half an hour or more and then do the adjustment. In my case, it took, to be honest, I didn't leave the transceiver on for such a long time, maybe 10-15 minutes, just to demonstrate how to adjust the local oscillator frequency. But I will try to leave it as it is for the moment, and it's the first time I've been doing this adjustment, but it's quite easy, I realize. So if I need to readjust the local oscillator frequency in the future, I will probably repeat this procedure. Okay, there is no frequency. Let's check it once again. It's 1003 hertz, right? So that's much better compared to the previous scenario when the audio frequency was 29 hertz off. So this is much better actually. Okay, so you really need a very small screwdriver with a very small tip. It's of a straight type, and hopefully you can do it yourself as well. Right, so I will make a stop here. I'm going to operate my transceiver for a while, and if I realize that again that the whole clock frequency is not exactly tuned, I will probably repeat this procedure. Okay then, hope this video has helped you to get a rough idea of how you can adjust the local oscillator of the frequency of your local oscillator for your 590SG Kenwood transceiver. And right, so I will probably come back with a new video if I need to repeat this a calibration procedure. So for the moment, see you later. Bye bye.